Okay, so now it's time for you to try some. Go ahead. The best thing you can do is practice this technique. So take a moment, pause the video, practice these by solving these 4 equations, then unpause the video and you'll see me work through them. All right, so x squared plus x minus 42 equals 0. We've got 0 on one side, so factor the other. You get the right color here. X times x, negative 42. To get a positive 1, I'm going to use a positive 7 and a negative 6. Set each factor, now that I have this factored, to 0. And solve these individual equations. So I get x equals negative 7, x equals 6. So the solutions, if I've done everything right, should be negative 7 and 6. I'll come back and do the checks on all of these after I finish all 4 of them. So sometimes it can, while you're in a rhythm, you can work on them and then come back and check. The next example, I do not have 0 on one side, so I'm going to move the x and the 4 to the other side because my x squared is positive where it is. So 3x squared minus x minus 4. So remember, when you move things, you change their signs. Then we're going to factor this trinomial, 3x times x. Now I need to factor the negative 4 to get a minus 1. I'm going to try a negative 4 here and a plus 1 here. I'm going to multiply that back out, and in fact it does multiply back to this trinomial. If you need some practice, I did trial and error there, but you could also use the AC method off to the side, whether it's the box method, show your box off to the side or on scratch paper, or the fraction method, that shortcut method we went over. But main thing is you need to be able at this stage just to factor a trinomial whenever it comes up with whatever technique is best for you. Now we can have a product equal to 0, so we can set each factor equal to 0 and solve. So the first factor, 3x minus 4 equals 0, add the 4 to both sides, divide out the 3, and we get a solution of 4/3. And the other one, it's a little easier, just subtract the 1 from both sides, so we get x equals negative 1. So it looks like our solutions are negative 1 and 4/3. We'll come back and check that in a moment. Our third example has a factorization on one side, but 18 on the other. So that factorization is useless. I'm going to get rid of it and move the 18 over. So I distribute the x, move the 18 to the other side so that I can have 0 on the right. You can have 0 on either side, but that was easier because I only had to move the 18 and it kept the x squared positive. Now that I have 0 on one side, I factor the trinomial that's on the left. So I have x times x. The negative 18, I can factor to negative 3 and positive 6 to add up to negative 3. Always take a moment and multiply that back out and make sure the factorization works for what you had above. Once you're confident, go ahead and set each factor equal to 0 using the zero product principle. So we get x minus 6 equals 0 gives us x equals 6 by adding 6 to both sides. X plus 3 equals 0 is x equals negative 3 by subtracting 3 from both sides. Looks like we have 2 solutions. Those solutions are negative 3 and 6. It doesn't matter which one you write first or second. Often it's tradition in mathematics to write the lower number first, but it is your choice. I'm not going to mark you wrong if you write it as 6 and negative 3. And our fourth equation here, we actually have a cubic. So remember, with cubics, you'll often end up with 3 answers. But let's go ahead and work through the process. We don't have 0 on one side. So the first step is let's move that 36x over. So 4x cubed minus 36x equals 0. Always look for something common first. We have a 4 that goes into both terms and an x. So take both the 4 and the x out. We're going to get x squared left in the first term minus 9 in the second term equals 0. So now I have a product, but inside of the parentheses I still have an x squared, so I can factor that further because this is a difference of squares. So 4x times x plus 3 times x minus 3. Remember, a difference of squares will factor to conjugates. Just undo the squares, giving you one of each sign. Now we can set each of these factors equal to 0. Technically, there are 4 factors. There's the 4 in front, the x kind of in the middle, the x plus 3, and the x minus 3. 4 can't be equal to 0, so we can actually just leave that alone and just start with x equals 0, which is a solution. X plus 3 equals 0 would give us x equals negative 3, and x minus 3 equals 0 would give us x equals 3. So we end up with 3 solutions. So the solutions are 0, negative 3, and positive 3. All right, now that we've solved all 4, let's go back and do some checks. I'll do the checks in green. So on my first equation here, I'll come up and I'll check the negative 7 first. You always go back to the original equation. Negative 7 squared plus negative 7 minus 42 equals 0. We have 49 when we square minus 7, or plus a negative 7, minus 42. 49 minus 7 is 42, minus 42 is 0, so that checks. So our first solution does work. Then checking the 6. 6 squared plus 6 minus 42 equals 0. Let's check that. 36 plus 6 is 42, and when we subtract the 42, we will get 0. So that one checks as well. All right, our second equation, we're going to check negative 1 and 4/3. If I start up here with a negative 1, 3 times negative 1 squared equals negative 1 plus 4. Negative 1 squared is positive 1 times 3 is 3. Negative 1 plus 3 is also 3, so that first number checks. Then let's check the fraction. This may take us a little bit more work. 3 times 4/3 squared equals 4/3 plus 4. So remember, with fractions, when you square a fraction, you square both the top and the bottom, so 16 over 9. To add fractions, we need a common denominator. Right now we have a denominator of 3. Let's add a denominator of 1, because 4 over 1 is just 4. So to make that 4 over 1 have a denominator of 3, I'm going to have to multiply top and bottom by 3, so I get 12/3. So when I go to simplify these two sides now, remember 3 over 1, the 9 and the 3 have a 3 in common, so when I cancel those out, on the left I get 16 over 3, and on the right 4 plus 12 is 16 over a common denominator of 3. So a little review of fractions with that problem, but we do get the same result on both sides. So I do have the correct solutions in that second example. Our third example, we have 2 solutions, negative 3 and 6. I'll check those each individually. Always go to the original equation again. Negative 3 times negative 3 minus 3 is equal to 18. Work on the inside first. Negative 3 minus 3 is negative 6. Negative 3 times negative 6 is 18, so that checks. Then working on the 6, 6 times 6 minus 3 is equal to 18. 6 times 3 is equal to 18, and that's true. So that checks as well. In our last example, we have 3 solutions to check. Let's see if I can squeeze these in, all 3 of them in. 0 is going to be pretty easy because 4 times 0 cubed equal to 36 times 0. 0 equals 0 checks because anything times 0 is 0. So that first one is pretty straightforward. Then trying the second one, 4 times negative 3 cubed equals 36 times negative 3. Take your time here. Negative 3 cubed is negative 27. 4 times negative 27. If you need to, you can use some scratch paper to write that out. Is that equal to 36 times negative 3? Well, work it out. 27 times 4. Starting with 4 times 7, 8, carry the 2, 10, we get negative 108. Over here, 36 times 3, work it out. 6 times 3 is 18, carry the 1, 9 plus 1 is 10, and it's a negative. So that one checks as well. And then the 3, I'm really running out of room, so I'm going to do a little cheating here. The only difference between a 3 and a negative 3 is that I would have a positive right there, which would result in a positive 27, which would be a positive 108. If I check the other side, 36 times positive 3 would give me 36 times positive 3, or positive 108. So that positive 3 checks as well. That's kind of me saving some space by using a different color to check the calculations. So all 4 of these equations we did have the correct solutions on. Remember, always check your solutions in the original equation.